Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, girls. How are you?
Fine.
Alhamdulillah. Alhamdulillah. Happy National Day for everyone.
And for you.
Yes, and for all of us here living in this country. Okay, guys. Yesterday we were talking about the investigation process and how scientists do the methods and use them. And also we stopped in explosive observation. We learned that there is a repeated observation. Where can we use it, where or what time we can use it? Why do we use a repeated observation? Why do we repeat our observation? To learn about what? Girls, remember yesterday? Things that you can control and things you can't control. What about whales? Yeah. Okay, can you tell me?
There, but it's fine.
Yeah, and I missed you so much. Are you okay?
Yes, but I missed the science class. I thought there wasn't
Every day you
period
have
that
a science class. Don't miss that, all right? Okay, now anyone, Fairuz, do you remember? Jude, Amal. Yes, dear.
I wish I was there because I was going to answer. Miss, can I tell you something about the lesson of
Yes.
today? A voice really does shatter a glass.
Okay. About control, observation, and uncontrolled things, what do we control?
I know.
Yes, Tala, what do we control?
We can control the experiments that we can do, but we can't control the nature, like hurricanes and like volcanoes.
Good job. What about animals? Can you control animals if you want to know how do they live, how do they behave, or how do they take care of their young kids?
You can't really control them, but you could see them. How do they
Act.
Yeah.
Exactly. Okay, I have to see them every day and repeat my observation every day for a long time so I can study them. Is that right?
Right. If you just stayed with them one day, you're not going to really know what are they doing.
Exactly. Good job. Okay. Now let's see. Yesterday we did this practice. We did know how do they predict about volcanoes based on observation from millions of years. They were observing the volcanoes and the eruptions, and they pointed them, they made them on a map, and then later we can predict which time they will be erupted and which time not. And it's all prediction, so it's not 100% sure. Okay, and we stopped at models. We talked about models. We said that we have supermodels, complex models, and simple models. Simple models are these, the one you built with your own hand, okay? And it looks very simple, not really complex, but if you are doing it on computer or something really huge, it can be complex. Is that right?
Yeah. Right. Miss, can I ask you something?
Please, yes.
How do you know that a volcano is going to erupt?
Oh, okay. we know that a volcano is going to erupt not now. We know that the volcano this time of this year always have an eruption, so we can predict that at this time of the year or this time of this month the volcano might be erupted. See, you can't know very sure 100%, but you can predict and you can think, but you cannot be sure very much. Later, sometimes when it's very close and it's really going to happen right now, I think you feel something like an earthquake.
Vibrate?
Yes, a vibration. But I think before that, few minutes or sometimes few hours. So you never can know for sure 100% because it's nature and it's all in God's hands. We don't have
Control.
any control in it. Yes, exactly. Now models. If you want to make let me say, you want to make a model about volcano and how it's going to be erupted and when it's explode. Can you make a model of it?
Yeah.
Good.
Yeah, we can.
Is it complex or simple? What do you think?
If you're going to make it bigger, it's going to be complex. If you're going to make it smaller, it's going to be simple.
Okay, let me tell you, if you are going to make it big and maybe connected with a computer or electronic
Yeah,
device,
that's going to be
that will be
complex.
complex.
Yeah.
Yes, yes. So we know types of models. When modeling is needed, can you read for me, Jenna, please?
Okay. When modeling is needed, when scientists connect experiment with the real things, they can use models. Scientific models are needed to understand systems that have many hidden parts, such as ant colony or the
Colony.
or the colony
You know
or
the
the
ant colony? You know what does that mean? Ant colony? Mariana, do you
no.
know what's an ant colony?
It's like a house for ants.
Yes, excellent. The place that they take for living. Okay, complete, Maria. Such as an ant colony or the internet. Can you complete, dear Maria?
Yes. Scientists draw conclusions and make predictions by studying their models. The closer the models represent the real thing, the more useful it is. So scientists change their models as they learn more.
Excellent, excellent. So modeling is really important to help you learn more about the thing that you are learning. Also, when it looks very close to the real thing, it is easier and it is very accurate.
Some engineers they make model to see how
Excellent,
the house
yes.
will run.
Yes, exactly. So modeling is really important to help you understand or to help the workers who are going to work on this house or build this house to do it. So it's really very useful and helpful. Now, types of model, let's read that. Fairuz and Jude and Amal, three of you. I want you to read. I will start with Fairuz. When I say Fairuz, stop. Amal will continue. When I say Amal, stop. Jude will continue. Okay?
Okay.
Fairuz.
Miss, I read first one.
What?
Types of models.
Do I read the one scientist cannot experiment?
Types of models.
Oh. Models are made in different ways. One way is to build a physical model. An earthquake shake table with model buildings on it on it is a physical model.
Excellent. Thank you. Thank you. Aman?
Another way is to program computer simulation models. Scientists can speed up time in computer models so that they can see what might happen long in the future.
Thank you. Jude?
Drawing models. These two
No. Drawing diagrams.
drawing diagrams and
Flow charts.
flow charts is a third way to make models. These two
Dimensional models can be
dimension models can be used to show how ideas are related.
Good job. Excellent. So from this paragraph, we learned that there are 3 types of models. The first one is physical model. What do I mean by physical model? Physical model is something is going to move. Anything related to movement is a physical model. Just like an earthquake shake the table with model building on its physical, it is a physical model. So when you shake the table just to see how earthquakes happens, so this is physical, something moving. The second one is what?
I know.
Yes. Yes, Tala.
There is also
a computer simulation. Give me an example of a computer simulation.
Like when they see how volcanoes erupt, maybe.
Okay, let's say when a pilot is training for for flying. He wants to be a pilot. He wants to be first thing they do for him as a training. He put him in a computer simulation, even for cars. If you are going to drive and you want to take your license, you have to pass the computer simulation exam. Yes. So these are very helpful. Let you learn more about driving or flying or even other stuff. It's just like the real thing, but it is simulation. It's only computer program.
It's not real, it's just a robot.
It's just a computer program, yes, but it's really near to the real thing, real stuff. So it is helpful and it is useful. The third one is drawing diagrams. When you draw diagrams and flow charts, this is what? These models, yes, these models can be very useful. Yes, Tala, what do you know?
That when you get to train in an airport or something, it's not the same when you go up in the sky because there's like vibrations and sounds.
Yes.
So this is not the same as when you're in the ground.
Exactly. They try to give you things look like the real one, but when you are using the computer simulation, it's not real. So
I learned it from an air crash investigation.
Nice. Good job. Now look at this picture. This picture, ya Maria, shows what? What model? Which type of model shows? Yes.
I know.
Maria?
A house.
Okay. Is it physical, drawing diagrams, or the first one?
Miss,
The second
I know.
Yes, it is physical because scientists built tables that model the motion of the real earthquake. See, the motion or the movement. This photo shows 2 types of houses being tested. Which house seems to be safer in the earthquake?
I know.
Jenna, wait a minute. Jenna?
Yes.
Yes, Jenna, which one seems to be safer?
The last one.
The one in the corner. Good job. Excellent. Okay, now you have on page 29, you have a small exercise. I want you to do it. Look at these two boys and girls, these two, okay. You can model the effect of an earthquake using gelatin for the ground and buildings made of blocks. Let's see.
Oh, gelatin.
Yes.
The jelly that you eat.
Okay. How is an earthquake model made of gelatin like a real earthquake? And how it is unlike the real earthquake? I want you to tell me what are the things that are alike and what is different. Try to think, and why did we use it as a model? And remember, girls, models mean they must be very close to the real thing. Okay? Now I want you to take 2 minutes and I'll be back to you and ask you about the answer. Okay, guys?
What do we do?
Try to answer this question. It's in page 29.
Okay, that means we just like see what are they alike in and what they are different in. Okay.
Yes, what are the things that alike and what are the things are different?
They're both houses.
Okay, do you have an answer?
Yes.
Yes, tell me how they are alike.
They can both fall.
They
The
can
boats
both.
can fall.
Yeah. Excellent. Good job. What about the difference?
The earthquake has also air. So, but in the alike, there is no air.
Excellent. Good job. Good job. Jury? Is that Jury?
Yes.
Yes. Yes. Good job, Jury. Excellent. MashaAllah, tabarakallah. Let's see what is my answer. And girls, all answers are accepted. The ground shakes back and forth. So both of them, gelatin, will be shaking just like the earthquake. Okay, back and forth. Can you shake a gelatin?
Yes.
Yes, and it will be shaking just like the earthquake. When the earth is shaking and the gelatin is shaking, the one different thing is the ground is not made of gelatin and buildings are not made of plastic blocks. This is the one thing is not alike, okay? Do you understand, girls?
Yes.
Okay, good. Now we have only 5 minutes. We'll see what do we have here. How to excel in experiment. Take a very quick look to experiment. What do you need to make your experiment and to make it successful, huh? Do you have any idea? If I want my experiment to be very good, what should I do?
I know.
Yes, Tara.
You need to repeat the models.
Okay.
Repeated observation.
Okay. But every time I need to repeat my observation?
Not really, if you need to. And the thing, like you, when the things are in nature, like maybe volcanoes and stuff, you need to do a repeated observation. Or if you need.
Okay, if you are not doing something about nature, you are testing the water and how water will change if you add salt or if you add sugar, or if you add maybe lemon juice, vinegar, whatever.
You don't need repeated observation. You just do an experiment.
So first of all, you need to ask a question about the experiment. Number 1 is to asking question about the experiment. Number 2, you have to make your hypothesis. You need to hypothesize. And hypothesize means to try to answer this question that you ask in first place and make a test about your hypothesis or your hypothesis. After that, please design your experiment. To design an experiment, you need a variable. And the most important thing in your experiment is to control it. You have to control your things or your stuff.
Miss,
or
if
your
it's
tools.
not control, if you can't control it, it's not really that safe to make it.
No, it's not really, it's not, yes, exactly, but it's not only safe and not safe. It's not safe, yes, of course, but it's not an experiment.
Maybe it's not, oh.
It's not an experiment if you cannot control all the things and all the variables. Experiment let you be the leader of your own thing, okay? You can put salt in water, you can put vinegar in water, you can put color in water, because you need to try, you want to try, okay? If you cannot control what to put in water, so it's not experiment, it is a repeated observation. Is it obvious? Is it clear?
Yeah. Can I tell you something?
Yes?
There is a nice, like in Netflix, there is a nice, like educational, like not TV show, but it's something in Netflix. It's called Emily's Wonderland. It's really nice. They always do experiments, and then you could also learn from them. I
Nice.
Yeah, I know it.
But it's just 10 episodes. They still didn't post.
Okay. Good.
Really
I'm happy to hear that you are watching things are very useful and helpful to help your knowledge grow more and more. Okay, guys, please, I only ask you before Sunday, okay, before Sunday, our class, read these 2 pages and we will discuss about them on Sunday. Agree?
Agree.
Deal?
Deal.
Okay, great. I love you, grade 5, and I enjoyed this session with you. Hope to see you well and safe on Sunday. Enjoy your vacation, small vacation, and celebrate the National Day to the max. Okay, guys?
Bye.
Okay, bye.
Bye. Take care of yourself, girls. Bye.
Bye.